Good afternoon, everyone. Welcome back to the afternoon session online faculty development program on artificial intelligence, machine learning, and data science with research application. Uh, a special welcome to our resource person, Dr. Mettu Srinivas, sir, Department of CSC, NIT Warangal. Welcome, sir. It's my great privilege to read Dr. Mettu Srinivas, sir, profile. Dr. Mettu Srinivas, working as an associate professor in NIT Warangal Department of CSE. He completed PhD from IIT Hyderabad, MTech from JNTU, BTech from JNTU Hyderabad. He also worked as doctoral from Academia Sinica, Taiwan, and Phonetic Engine IIT Hyderabad. He won the early research paper award titled Performance Optimization Approach in Distributed Computing Platform in IEEE CCEME PCW 2022. Selected for Global Distinguished Young Scientist Award from 2023 IEEE IAS Global Conference on Renewable Energy and Hydrogen Technologies. Selected for INAE National Frontiers of Engineers Conclave. He received He published 15 plus international journals, 39 plus conferences. He worked with different funded projects. He published many books in AI, ML streams. He served as programming committee members in many international conferences. Now I request Dr. Srinivas sir to take over this session.
Yeah, thank you, madam. Thank you very much. I'm audible?
Yes, sir.
Yeah, thank you. Can you allow sharing option?
Yes, sir.
Sir, you can present right now.
Yeah. Yeah, my screen is visible.
Yes, sir.
Yeah. Yeah. Good afternoon to all the participants. So in this session, I want to discuss about the deep learning concept basics related to deep learning. And before going to the deep learning, I want to give the some introduction about the why different domains is came into the picture and what is the relationship between these domains. I need to discuss that one. Then after that, I need to go for the introduction about the deep learning and that I want to discuss in this session. So basically, current days we are listening the many buzzwords kind of thing like artificial intelligence, machine learning, deep learning. So many other terminologies also we are listening like data science, text mining, NLP, computer vision, medical imaging. So why these many terminologies are these many domains came? What is the relationship between these domains? Any relationship is there or all are same or not? I give the clarity on that. Then after that, I need to go to the deep learning interaction part. So basically, we are talking about the artificial intelligence. So what is mean by artificial intelligence? So artificial intelligence is the simulation of the human intelligence into the machines. That machines we can call as a AI. So for example, when I'm talking about the AI means immediately we remember the some kind of robo kind of thing. So basically two type of robots is there. So one is we can see in any manufacturing companies like big manufacturing companies, we can see the some type of robots is there. So for example, you can consider the car manufacturing company. So in the car manufacturing company, different stages are available. Like one stage they will do the assembling the car body parts. Another stage they do the welding of the car. Another stage they do the coloring of the car. So in that big manufacturing companies, usually humans are not involved all the stages. Some stages, some machines will be involved. So that machines, you can see the, for example, one place they want to do the car body assembling kind of thing. So in that case, what will happen? So body of the car will come. So here one robo is there. So that want to fix the car door. So when car body came, immediately this robo pick the car door and try to fix it in the exact location of the car door. Okay. So normally, suppose if you are rotated the some angle of this car body, then what will happen? This robo not change the angle of the door. It try to fix in the same how the previous activities they did. The same way it will try to fix it the same position. Okay. So in that case, the robo act like a human, work like a human, but is not think like a human. So this type of the robots not comes under the complete AI kind of thing. So which type of the machines, how the human intelligence is working, the same way they build the machines. The machine also act like a human, work like a human, think like a human. That machines only we can call as a AI, artificial intelligence. So in that case, for example, another type of the robo is there. So that is the one robo is Sophia robo is there. So in that case, if you approach the Sophia robo and you ask some question like, hi, how are you? Then what will happen? So it is related kind of response. So how the humans will be respond to the same question. The same Sophia robo also give the same type of the response. Like, okay, I'm fine and a good kind of thing. So that type of the robots we can call as the AI. So in that case, the robot think like a human, work like a human, act like a human. If you give the task, it will be how the humans will be act on the task. The same way it will be act, same way it will work, and same way it will think and it will give the response. So that robots only we can comes under the A. So A many kind of techniques or methods are available, like logic based kind of methods and search based kind of methods, and another one is the learning based methods is there. So that learning based methods we can call as a machine learning. Okay. So what is the machine learning? So machine learning is the one of the application of the AI. Machine learning is the one of the application of the AI. So in this system ability to provide, okay, based on the past experience without explicitly provide any extra new information, it will be provide the better performance. Okay. So machine learning is the one of the application of the AI. So in this system ability to improve the performance based on the past experience without explicitly we are providing any new information, means we are not giving the future related information. Based on the experience means past experience. So based on the past information only it will be predict what is going on in the future. For example, earthquake prediction kind of application or weather forecasting kind of application, or you can consider the you can go to the 4 5 years back. 4 years back we have the suffer with the COVID. So COVID early stages like April May, that time most of the machine learning researcher, so which is the data is available, based on that they will do the prediction or analysis kind of thing, means how the spread rate is there, how the death rate is there. So they did more accurate kind of thing. So the same way you can consider the weather forecasting. Nowadays you can see weather forecasting also give the more accurate results kind of thing. So today afternoon or maybe tomorrow morning, like this type of the rains come, any what type of the heavy rains or normal rains will come, any rain will come or not. So they accurately predict and they give the report. How they will predicting? Based on the past information. Past information means what? How the yesterday temperature is there, humidity is there, wind speed is there, any rains is happen or not, what type of the rains is happened. So based on all this information is collected, based on that, this is the past information. They will provide what is going on in the future. Okay. So that will be doing the machine learning. So machine learning basically three type of learning methods is there. So one is we can call as a supervised learning method. So another one is the unsupervised learning method. And one more is there, that is we can call as the reinforcement learning. So these are only learning methods. So most of the people working on machine learning researchers are working on supervised and unsupervised learning methods. 60 to 8, almost 70 to 80% of the researchers. Only like 10 to 5% of the people working on the reinforcement learning kind of approaches. So reinforcement learning approaches where they will use, where they want to take the any dynamic actions. Okay, so in that scenario only they will use the reinforcement learning algorithm. Okay, so basically I'm talking about here the supervised and unsupervised learning method. So if I ask the question, what is the difference between the supervised and unsupervised learning method? So most of people knows, they will give the simple answer. Supervised means it is contain the labeled data. Unsupervised means it is the unlabeled data. Means there is no labels here. So in each category, either supervised or unsupervised, many different type of techniques, methods are available. Like if you consider the unsupervised learning method, they use the another term is called the clustering. Okay, so clustering is nothing but is the process of grouping the data objects. How they will group, which are the apps, if the objects are similar objects is there, they make them as a group. Okay, so in this many techniques or methods are available, like partition based clustering algorithm, density based clustering algorithm, grid based clustering algorithm, hierarchy based clustering algorithm, model based clustering algorithm, and each category also again the multiple techniques or methods are available. Now come to the supervised learning algorithm. In this also many techniques or methods are available, like naive Bayesian classification method, decision trees based classification method, KNN based classification method, and support vector machine based classification method. And one more is there, that is called the neural network. Okay, so how the our biological neurons are working, because every human have the brain is there. In the brain consists of some billions of neurons is there, and trillions of connections is there between these neurons. So how the biological neurons are working in the human brain, the same way they build the artificial neural network. The simple form they will call as a ANN. How the our human biological neurons are working, how the our biological neurons are connected, how the biological neurons competition is going on, like a competition is going on like parallel and distributed manner. The same way they build the artificial neural network. The simple form they will call as a ANN. So basically, just I give the outline of the ANN here. So ANN consists of a three type of the layers is there in multi-layer perceptron kind of thing. So what are the three layers? One is input layer, hidden layers, and output layer is there. So input layer, normally what the your input data is there, you can given as a input layer. So that is your features, feature representations just to feed into the your network. Okay, that is input data. And here hidden layers is there. So the question is how many hidden layers I need to choose it, either 1 or 2 or 3 or 4 or n. So that is up to you. You have the good computational facility is there, then you can take the n number of hidden layers. It's up to you. Or you can take the 2 or 3. You not have that much of computational facility. Very small memory kind of system is there, and processing speed also very slow is there. Then you can take the less number of hidden layers. And here, so input data means your feature vector data only. That you know, for example, my input feature vector data 30 cross 1 is there, means 30 properties I am using. But what about how many nodes I need to choose in the hidden layer? For example, hidden layer 1 is there. Here, how many neurons I need to choose it? How many neurons or nodes I need to choose it? That is also up to you. Suppose you want to reduce the dimensionality of your data compared to your input, you can take the less number of nodes compared to the your input size. For example, input size 30 cross 1 is there. Then here take the 20 or 15 or 10, it's up to you. Or you want to take equal or more also, you can take it. More means you can take the 40, 45, 50, like that also you can take it. So that is how to choose the number of neurons or nodes in the each and every hidden layer. Then finally, you know, each hidden layer output is input to the next layer kind of thing. So like this fully connected kind of connections is there. Each connection have the some weight is there. Okay. So finally output layer is there. So each hidden layer output is again input to the next layer, means here next layer is output layer is there. So it given the input connections like this. Okay. Then finally you can get the output. So here in the output layer, how many neurons I need to choose it, either 1 or 2 or 3, how many I need to choose it. So that is depending on the how many class classification task you are doing. You are doing 2 class classification or 3 class classification, that is up to you. For example, your task is the 2 class classification, means binary classification, either 1 or 0 or no kind of thing. So in this case, you can use the two nodes. Okay, in the output layer, how many nodes you need to use it? Two nodes. For example, your task is the digit recognition. So digit recognition, how many digits is there? 0 to 9 digits. Total, how many values is there? 10 values. So how many nodes I need to choose in the output layer? 10 nodes I need to choose it. For example, my task is the 1000 class classification problem. Total, how many classes is there? 1000 classes is there. Then in this case, how many nodes I choose in the output layer is 1000 nodes I need to choose it. So that is the way how to choose the number of neurons or number of nodes in the output layer is depending on the how many classes classification task you are doing. Okay. So for example, you are considering the more hidden layers kind of in this architecture, then that architecture they will call as a deep neural network. We are using the more number of hidden layers in this architecture. So this architecture they will call as a deep neural network because it is appeared as a more deep kind of thing because many hidden layers you are using. Okay. And before this input layer, for example, input layer also I am represented with the some nodes kind of thing. So before this input layer, you can add some more extra layers. You add some more extra layers. Then how the architecture still look like? It is again look like a more deep kind of thing. Then that is only they use the terminology deep learning. So deep learning is the just extension part of the artificial neural network. Artificial neural network is the one of the supervised learning algorithm. Supervised learning algorithm is the one of the machine learning technique. Machine learning is the one of the application of the AI. So these all are comes under the AI only. Okay. So here in the before going to the deep learning, what is there in the traditional machine learning? The important stages in the machine learning is the feature representations or feature extractions. So feature representations or feature extractions is the one of the important stage. So almost 70 to 80% of the your accuracy depending on the what type of the features or what type of the properties you are extracting from the data. Your features or properties are good, then it will give the good classification results. Suppose your properties are not good, what your extracted properties or features are not good, even though you are using the best classification method, because your task is a classification task. Your classification task, you are using the some classifier. I said already, I given the list of the classifiers. For example, if you feel support vector machine is the best classification method, but your features are not good, even though you are using the best classification method, it won't give the good accuracy. It will be decrease your accuracy or increase the error kind of thing. Okay, so that's the reason in traditional machine learning, one of the important stage or important part is the feature extraction or feature representations. So always we can look for the better features to get the better accuracy. So what are the features means? It gives the unique information of each and every class and give the more discrimination information between the classes. So that type of the features only you need to select it. Okay, so in that case, just I will take the some features. Then after that, I need to go to the deep learning mechanism. So for example, how the one textbook is there. Okay, so in this textbook, what will happen? One front page is there. So the front page we can call as a cover page. Okay, so usually this cover page, what is contain? Title of the book, author names, publisher name, year of publication. So this type of the information is available only in this front page only. And inside the pages does not contain the this type of information. Only it's contain the front page. Suppose what I did, I removed this front page. Okay, I removed this front page. Then I given this textbook to you. So I told you can read this textbook. So after the once your reading is completed, then you can approach to me. Then you take 15 days time. So after 15 days, your reading is completed, then you approach to me. Then I'm asking the question, can you recognize this book is related to which subject? It is possible or not? Normally, usually we can recognize the book. How you can recognize? Based on the content. Based on the content. So content is nothing but what? Here content is what? Book. Book is contain the what? Pages. Page contain the what? Paragraph. Paragraph contains what? sentences. Sentences contains the what? Words. So here you are not considered the entire content of the book. You can consider the only particular words. That were based on the words only you are taking the decision or identify this book is related to the which subject. So that words we can call as the special words or keywords. For example, after in reading the book, you identify the some words like this: entity, relationship, primary key, foreign key, normalization, transaction minimum. Then the book is related to which subject? Database management system. It's related to database because you have the tables is there, tables contain the attributes is there, and entities is there. You have the maintain the relationship between the attributes. You have the primary key, foreign key, normalization kind of techniques is required. So in this case, maximum how many words I given? 6 to 7 words. Suppose if you go and search any DBMS textbook, how many words is there? More than 5,000 words is there. More than 5,000 words is there. But here how many given? 6 to 7. So here this 6 to 7 words is what? Special words or keywords. Based on that, we are easily identify and recognize the book is related to which subject. Suppose another example I am considering. So after reading the book, you identify the words like this: semaphores, monitors, critical section, kernels, jobs, scheduling. Then the book is related to which subject? Operating system, OS, because you have the you want to perform the some task. You need to require the kernels to perform the jobs. So for that one require the scheduling algorithms. So in this case also, how many words I given? 5 to 6 only. But if you go really this textbook and search it, how many words, total number of words is more than 5,000 is there. But I given only 5 to 6. Based on that, you identify the book is related to which subject? Operating system. So here you selected words is enough to get the concept, or maybe that is related to which subject. So this is the in textbook case. For example, this FDP is going on physically. Then I came to your college. Okay. Maybe your coordinator is introducing about me. Is the Dr. Srinivas from NIT Warangal. Then when you're seeing on first time, what is going on in your brain? So how my physical appearance is there, like my height, my personality, my gesture, my eyes, my nose, my skin color, my hairstyle, all this information will be extracted and that will be stored into your brain. Okay. So normally, usually, suppose you are meeting the new persons. After some discussion is completed, maybe you want to take his or her phone number. Then what you'll do? First, you can open your mobile contacts. First, enter the number. Then after that, you enter the name. Suppose you enter the name like Srinivas. So like this, you enter the name Srinivas, but already in your contacts, some with the same name Srinivas already existed. Then what you will do? You can go ahead with the same name, or maybe you can add some more extra. So usually you can add the extra. Why you are adding extra? Because you want to discriminate the Srinivas person with this one to other persons. You need to add the extra thing, maybe the organization name, or maybe surname, or maybe place name. So like that we can add it. The use of this one is you need to easily discriminate the one person with the another person contacts. So here what you written like saved with the name. So this we can call as a class name or tag name or label. All are same only, class name, tag name or label. So this class name, tag name, labels are mostly used to uniquely identify the objects. So this object is apple. Apple is nothing but the label. This object is orange. Orange is the label. This is the dog. Dog is the label. This is the cat. Cat is the label. Like that, you can use this label to identify the objects. So this is happened in every human brain. This kind of activity is going on. Suppose this FDP is completed. Okay. Then after 20 or 30 days is over. Then again I came to your college. Maybe that time I will be there in the your college canteen, or maybe your college another seminar. So when you're seeing on me on second time, can you recognize me or not? So usually when you are seeing the second time persons, we can recognize. How can you recognize and what is going on that time? So when you're seeing the same person second time, same how the first time what type of the information is extracted and stored into the brain, the same type of the information is extracted like skin color, eyes, nose, hairstyle and dressing style, personality, gesture, walking style. All this type of the information will be extracted and that will be compared with the already stored in your brain information. Okay, that is compared with the already stored in your brain information. So within the fraction of seconds only we can recognize, okay, is the Srinivas from the NIT Warangal. So that is daily activities going on in every human life. Okay. So here, otherwise, can you see on my top of the face, any biodata is there with words like any my top of the forehead or near to my face, like Srinivas, NIT Warangal, CS department, like that, anything is there? No. I'm the not the textbook. I'm the human means human related information was the available. Human related information means the physical properties like height, personality, gesture, walking style, colors, skin color, or eyes, nose, lips. This type of the information only is available. Okay, so this is one another type of the application. For example, one more application is there. Daily we are listening some kind of music related kind of things. So normally the music will be stored in the form of the signal. So I given this signal, then am I asking the question? This is the what is the signal? The signal is music related signal or speech related signal. If it is a speech related signal, who is the speaker? X or Y or Z? Who is the speaker? Then if it is a music related signal, what type of the music? Like pop music, that is X person or Y person or Z. Machine learning. So in that classification, what you will do, any supervised learning algorithm used to classify the different documents. So in that case, they use the terminology is called the text map. Suppose I want on the medical image data, it's like X-ray images, CT scan images, PET scan images, X-ray images, like this many different type of the medical scanning image data is available. So in that case, what will happen? They need to use the machine learning algorithms to classify whether it is normal or abnormal or any other kind of the classes. So here also what will happen? You are using the medical data, they use the terminology is the medical image. Like same for computer vision kind of application also. So like that many different data sets are available, they given the different terminologies. But one thing you remember it, the important stage in the machine learning is feature representations. Your features are good, then it will give the better outcome. Your features are not good, it won't give the better results. So some of the already standard methods are existed in the traditional machine learning, but that is not sufficient also. You need to come up with the sometimes new techniques, new feature representations also. Okay, like for example, if you already knows some color based feature representations is there, some shape based feature representation is there, some texture based feature representation is there. So this color shape texture based feature representation, they use a terminology is called the global features. So sometimes you can go with the local features like shift features and surf features and brief features and hog features. Like this, many different type of techniques or methods are available to extract the feature representations. Okay, and these also not sufficient. You need to come with a new method, new approach also. Okay, so sometimes the color based methods will work for some kind of applications, and some cases shape based features are work for the some kind of applications, and sometimes texture based features are extracted for the some applications. Sometimes these three, you are using these three also not helpful. You need to go for the local features. Okay, classification also is available. Here one more intermediate stage is there, that is called the dimensionality reduction, DR. Simply they use the terminology is called the dimensionality reduction, DR. So what is the mean by dimensionality reduction? Means it will be reduce the dimensionality. So reduce the dimensionality means automatically it will be get the better dimension, lower dimension kind of thing, and it will be going for lower dimension. It will reduce the time complexity kind of thing, and it will become to the fastness of the computing. So dimension reduction also not compulsory. It is also optional depending on your data requirement. Any dimension reduction is required, then apply the dimension reduction method. Otherwise, no need to apply. Okay. Then finally, what will happen? This classification method, what it will generate. So it will train the model. Okay. With help of the training data, it will be train the model. Finally, generate the output as a model. So model is nothing but what is a set of model is nothing but set of rules or set of parameters. What parameters? Trained parameters. Set of rules or set of parameters. Okay. So now this everything is happening in the training stage. Now your test data is there. So test data also how the labels is there. The labels we can call as the actual labels or virtual labels. Then what are the stages you did in the training stage? Training stage. The same feature representations you can use it. Okay. So for example, you apply the some XYZ as a pre-processing method. The same pre-processing method you can apply for the here testing case also. Suppose you not applied any pre-processing method, no need to apply any pre-processing method. Suppose you apply the some dimension reduction method on the training phase, you reduce to some kind of X dimensionality. The same dimension reduction method apply on the your test samples, and that is also reduced to the some X dimension. If you not reduce, if you don't want to reduce any dimension reduction in the training phase, and no need to apply for the test phase also. Then after that you can give to the model. Then model what will do? Based on the model, it will be generate the labels for the data. So that labels we can, the labels means here test data labels will be generated. So that labels they will call as a predicted labels. So these predicted labels will came for the which kind of data? Test data only. But how to quantify the your results? Some different performance metrics are available, like accuracy and error kind of thing. Error also again the different type of the error metrics are available, like square difference or some of the square difference, some of the absolute square difference. Like this many approaches is available. So mostly what you need to do, already test samples have the labels is the original labels or actual labels. Then based on this, you can compare the your actual labels with the predicted labels. Okay, so based on this, how many correctly classified, then you can consider that is as a accuracy. How many misclassified, that you can consider as a error. Okay, so like that you can calculate the accuracy or error kind of thing here. So this is normally happen in the in your classification supervised learning algorithm. These are the stages is there. So one of the important stage, I said, yeah, the feature representation is important. So almost 80 to 90% or 80 to 70 to 80% of the accuracy is depending on the what type of the properties or features are you are using. Okay, so you are using the best feature representation, then only it will give the better outcome or better results kind of thing. Now that you see, these are the stages is available in the machine learning. Traditional, we can call as another term, we can call as a traditional machine learning. But now I want to differentiate between the machine learning and deep learning. So the difference is, here you have the data is there. From this data, you are extracting the properties, that is feature extraction or feature representation. Then after that, you are choosing your model, means your classification method you are choosing. Then it will generate the model at the time of the training phase. Okay. Now in the deep learning, we also have the data is there. So instead of extracting the features, we are not extracting any features. The feature extraction plus prediction, means classification, both are taken by the deep learning model. So feature extraction, it will be itself is the extract, and it will do the prediction also. Prediction is nothing but classification. Both will be do. So directly data give to the this prediction model. So only in the machine learning, we have the one of the important stages, the feature extraction is there, so that you can use the existing model, existing methods, or maybe you can come with the new techniques. But here in the deep learning, what happened? That part also not there. That is also removed. Then you can easily do the prediction or classification. See here, you have that this is the traditional machine learning algorithm or conventional machine learning algorithm. You have the data is there. Next, you can extract the features, that is called the feature extraction. Then you can give to the prediction model. Prediction model means either support vector machine classifier or neural network classifier or any other classification method. Okay, so I said this is an important stage in the machine learning. Now we can come to the deep learning. How the data is there, we are not extracting any features. Just you can give the data to the your deep prediction model. Okay, the model only extract the features plus prediction. Both it will doing, extracting the properties and prediction, both are doing. So that is the advantage of the deep learning. So here this feature extraction part is not there in the deep learning. So the feature extraction part is take care by the your classification model itself. Okay, so it is only extracting the properties, and after that it will do the classification also. So this is the difference between the traditional machine learning algorithms and deep learning. Some other factors also is there that give the discrimination among the deep learning and machine learning. Now we see what are the factors is there and how the variation is going from between the deep learning and machine learning, we can see. So suppose you want to work on the deep learning models, you require the large amount of the data. So first point is what? Data requirements. So you are working on the deep learning. So how much data is required? Large amount of the data is required. In case of machine learning, less data is enough. If you not have the large amount of data, then you are using the deep learning, it will give the better results. But what is the issue will come? The issue is come overfitting problem will occur. If less data is there, your model will be overfitted easily. Okay, so to avoid that one, many people what they did, they do the augmentation kind of techniques, different ways to the augmentation. Okay, data augmentation techniques they will apply. This is the first factor to discriminating the deep learning and machine learning. So deep learning requires the large amount of the data compared to the machine learning. Machine learning is less data is there is enough, but even though in the deep learning little bit data is less is there also, it will give the better results representation. It will give the better outcome because of the way of extracting the properties are in the deep learning give the better representations. Okay, that is the first factor requirement or first factor. Next, accuracy. So nowadays deep learning models are widely used in many different type of applications, or it is not only image related, signal related, video related, everywhere they use the deep learning models. The reason is the deep learning models give the more accuracy compared to the machine learning. Machine learning give the less accuracy. This is another factor to discriminate the deep learning and machine learning. Now third point is training time. So normally, usually, you are coming to the traditional machine learning techniques. So one of the supervised learning algorithm is called the neural network. I'm right. So neural network, if you consider the multi-layer perceptron kind of thing, so how many layers is there? Multiple layers is there, like hidden input layers, hidden layers, and output layers is there. So you are taking the more hidden layers, then what? How the your architecture look like? So it is look like a more deep kind of architecture. I said already. But in case of deep learning, what you're doing, and before input layer, you add some more extra layers also. then again your architecture is look like a more deep kind of thing. Okay, so that is the deep learning. So here more number of layers is there, and the way of computing the extracting properties is the raw from the raw pixels. Okay, from the raw pixels it will be extracting the invariant feature representation related to the scaling, rotation, all this type of the variations related data extract. So definitely this training time for the deep learning is more and machine learning is less. This is another factor. And next one is the hardware dependency. So hardware dependency means you need to use the deep learning algorithms to run on the machines. So what type of the hardware is required? So in this case, GPU based or TPU based hardware only required if you want the deep learning models, because you can see that your computer means a laptop kind of thing or maybe desktop computer kind of thing. So how many cores is there in that one? Maybe you can see 4 cores or maybe you can see 8 cores. So like the 4, 8 like that is there. Or maybe you can go better system other than your laptop or desktop. Go to the department server. Then how many cores is there in that server? Maybe 20 cores or 40 cores kind of thing. But here in the GPU based hardware means we have the GPU card is there. So one card itself minimum 2500 cores to more than 5000 cores is there nowadays, which is available cards. Okay, minimum 2500 cores to 50,000 5000 cores is there. Then how much it will run in parallel, how much it will give the better results. It's not only run the program in parallel, it is run in the variable level in the parallel, not programming level. So even though that much, excuse me, even though you are running that much computation also, it will take more time to complete the your task compared to the machine learning. And hardware dependency case, so a machine learning normally require the CPU based machines only, like which is the regularly you are using your laptop or desktop, or maybe in your college what are the systems is there, that all are the CPU based machines. Okay, so that is for the machine learning. So these are the factors give the discrimination among the deep learning and machine learning. So next you can see the how the what are the deep learning models are available. Okay, so what they how the layers is there, what type of the layers is there, how the variation is coming from one initial model to another model. So that I want to discuss in the next. So here initially developed deep learning models, they use the one of the standard data set that is called the ImageNet data set. So ImageNet data set is the one of the huge database. Huge database means in this millions of images are available. Millions of images means more than 12 lakh images are available for training and 1 lakh available for the testing data. Okay, so it is the one of the classification problem related data set. So ImageNet is the data set. The name is the database name. So in this, how many samples is there for training and testing? For training, more than 12 lakhs images are available for training, and testing it's available 1 lakh. Okay, so total how many classification problem? 1000 classification problem means 1000 different type of the classes is there. Like flower related images comes under the one class, and some kind of computer related images comes under the one class, and some birds related images comes under the one class, and flag related images comes under one class. So like that, how many classes is there? Total 1000 classes is there. So that's the reason we can call as a 1000 class classification problem. So this is one of the huge data set in the image based real time image based kind of data. So here, how many millions of for training images? I said more than 12 lakh images for training, 1 lakh for testing. Okay. So who are initially developed their own models in the deep learning, they use this as a reference data set. They apply their method and they will test it, and how much results they get it, they projected. If they will get the better results than existing state of art results, they will say, okay, my method is giving the this much results are better than existing models, like that they claim. So here you can see how the variations came on the each and every year in the deep learning and between the machine learning and deep learning also in this slides we are showing. So until 2011 up to here, they use the traditional machine learning algorithms. So traditional machine learning algorithm means features are extracted, then that feature is given to the classifier, then classifier learn the features, and based on that it will do the prediction on the test samples. So that extracting features they will call the feature engineering. Okay. So after the 2011, from the 2012 onwards, this deep learning models came. The first model came in 2012. Okay. So this is the like a initial model is nothing but AlexNet model came. So in this few number of layers is there compared to the which is come later coming the layers. Okay, so initially when they use the traditional machine learning algorithms with the support vector machine classification algorithm. Okay, feature representations. What type of the features? Shift features, scale invariant feature representations with the support vector machine classifier algorithm they use. So they got the error rate of 0.28 and 0.26. Means almost 30% of the error they got it. But after that, when they're using the deep learning models, the error is drastically decreased to 16%. From the almost 30 to 16% means half of the error is decreased. Then after that, they build another kind of the model in the deep learning. So that is applied on the same ImageNet data set. So that is given the better results than compared to the previous one. Previous 16 is there, now maybe it is giving the 12%. So error is reduced. In 2014, again some more model is developed, that is like a VZ6919 kind of model. Okay, so in this case they apply the same, this layer is depth is increased, means more number of layers used compared to the previous one. So it is giving the better results than previous one. So 0.07 means 7%. So every year they come up with some modifications in the algorithms and compare with the which are the state of art results is there. So like this, every day they come up with some modifications in the techniques or algorithms in the layers. Then they will get the better results. Then they compare that results with the already existing state of art results. So if it is they get the better one, okay, they claim it. My method is to give the better results than existing one. Like that, they will claim each and every year. Okay. So based on the they're giving the better and promising results in the deep learning, they applied on the different applications, not only related to the real-time image data kind of thing. They applied the medical image related data also. They applied in the remote sensing kind of applications also, bioinformatic related. So many applications they applied this deep learning model, and many different type of the techniques came in the better and better. For example, if it's your data is continuous data is there, like sequence of continuous data is there, then they will go with the RNN, LSTM, BiLSTM kind of techniques they applied. Our data is a discrete, like image related data is there, they will go for simple CNN models, or maybe it is unlabeled data is there, then go with auto encoders kind of mechanisms to get the better model as a output. So this is the how the deep learning is introduced, and why a lot of improvement is coming from the previous to the next coming years kind of thing. Okay, now here we can see the some object. So what you are seeing the object here, some image. So the image contains the number of 8. Okay, so how you are visualizing this number and this 8? So you are visualizing this number of this 8 based on the pixels information. Each image contains the pixels, each pixel contains some value. That value we can call as a pixel intensity value or frequency value. So based on that intensity value or frequency values, we are visualizing the some shape of the object. So what is the shape of the object here? The digit 8. But all the cases it is all the same kind of object is there? No, depending on your data it will change. Okay, so here what type of the image is the binary image. So it contains the pixels, contain the only zeros and ones kind of thing. 0 is the black color, 1 is the white color. So where is the black color is there, that is contain the value is 0, whereas the white color is there, that contain the value is 1. Okay, so this is the binary cases images. For example, you can see in this image 3 little bit puppies is there. So it is the color image kind of thing. Each image you can contain the pixel intensity values. Okay, but our point of view, human point of view, we can see the shape of the object, but computer point of view, see the only numbers. The numbers is nothing but the pixel intensity values here. Okay, so this only it will see the pixel intensity values. We have the depending on the what type of the image you are using, color image or binary image or grayscale image, the values will be changed. The pixel intensity values will be changed. Okay. So here one image is there. In that image, some persons is there, bicycle is there, some compound wall is there. Okay, grill kind of compound is there. So how to extract the edge of the this image? So what is the advantage of the edge information? To identify the shape of the objects, maybe person or things, whatever it may be, this edge related kind of information will be useful. Okay, so how to extract the edge or edge information? So that we can see here. Basically, two type of edges is there. One is vertical edge, another one is the horizontal edge, and one more also is there, that is the diagonal edges. Vertical, horizontal, diagonal. So when you are extracting the vertical edge, what is the original image is there? The original image is converted into the binary image kind of thing with the vertical lines only. So entire object will be represented with the vertical lines. For example, here two persons is there. So the person will be represented with the this like this vertical lines. Head part. Hand is their hand part. Another hand part like this. For example, it is the you are applying the or extracting the edge information related to the horizontal edge. So horizontal means horizontal lines is there. So like this, it will be, for example, by say person is there. So the person will be represented with the like this horizontal lines kind of thing. So vertical lines, the entire shape of the object is represented with the vertical lines, and here horizontal lines means entire shape of the object will be represented with the horizontal lines. Okay, then the question is how to extract this edge information. How to extract this edge information. Now come to here. So this is my image of size 6x6 grayscale image. So grayscale image is nothing but what are the values content. The values content the ranges from the 0 to 255. So each pixel contains the only one value. That is either from the 0 to 255 range values it is contained. So 0 is nothing but almost near to the black color, and 255 and below 255 near to 255 values is contains the white color kind of thing. So like that values is there. Now I want to extract the edge information. So here I'm selecting the one filter. Okay, filter is nothing but a small matrix of size here 3x3 I'm taking. So filter is nothing but the small weight matrix or weight matrix or filter. So they have the kernel, some other name also is there, kernel. Different terms they use, kernel, filter, and weight matrix. So here how much filter size is there? The same size of the image size you can select 3x3. Then what are the pixel values is there? The pixel values are convolved with the corresponding filter values. Okay, it's a like a multiplication kind of thing, one-to-one multiplication kind of thing. So what are the pixel values is there that are convolved with the corresponding image pixel filter values. So what are the image pixel value? First one is the 3. Then corresponding filter value is 1. 3 into 1 plus. Next one 0. 0 into 0 plus. Next one is 1. 1 into minus 1. So first row is completed. Next come to the second row. So 1 is 1 plus 5 into 0 plus 8 into minus 1. So second row is completed. Now come to the third row. 2 into 1. 7 into 0 plus 2 into minus 1. So that is the your third row will be completed. So take the after multiplying the each image pixel value with the corresponding filter values, take the sum of the all the values. For example, after taking sum of the all the values, you get the output is -5. So this -5 is the input of the next layer, means which is the layer you to connect it to the that one. So you can consider this 15 as a means -5 as a your original input data. Not only -5, like this you can get the values. So here, so first it is completed from here competition. Next again the 3x3 of your image pixel select like this, and again convert with the corresponding filter values. And what you're getting the output, maybe output is 4 you're getting. 4 is the second output. So like this, after that is completed, again move one more step forward like this and convert this pixel values, the corresponding same filter values. Maybe your output is 2. After taking some of the all the input values, multiply with the corresponding filter values. Then next again move one step forward like this. Then convert with the, again pixel values with the corresponding filter values. Maybe output is 1. Okay, so left to right is completed. Once left to right completed, then you start from the top to bottom. Means skip the one row and start from the here again 3x3. Again, this filter values convert with the corresponding image pixel values. Then what you're getting the taking after taking some of the output value, the next second row first value. So like this filter is moving on entire image from the left to right and top to bottom. So finally it will reach here. Will be reach here. Then you are getting the last matrix of the output. Once you are getting this output, you project as a image. You project it as a image. This image look like a kind is look like a edge related kind of information. Means it contain the edge related data. Contain the edge related data. So what type of the edge related data? That is depending on the what type of the filter you're using. You're using vertical filter or horizontal filter. So it is a vertical filter means vertical filter related edge information is extracted. If it is a horizontal filter means it is a horizontal related edge information will be extracted. So like this, after the all the points completed, finally you can get the this is as the output matrix. Then this projected as a image. Then it's contain the edge related kind of information. Okay. So I said this is the your filter or kernel. So here what are the values you need to change, need to choose it depending on the what type of the edge information you require. For example, you require the vertical edge related kind of information, then you can take the vertical edge related filter. Okay, then convert these values with the corresponding image pixel values, then finally get the output. This is look like a vertical edge related kind of information. So it is clear. If you have any doubts, is there? I'm audible. Okay. So already in the traditional machine learning algorithm, they will develop already they develop some kind of filters. So that is already some filters are existed. You see what type of the filters is there, I will show in the next slide. See here some of the already existing filters. One is identity filter, another was the edge detection filters, different sizes of edge you want to extract, then you can use the different type of the filters. And you want to do the sharpness of the your image, then you can use the this matrix as a your filter. Or you want to blur the image, you can use the this is a filter as a to blur the box blur or Gaussian blur is there. So which type of the blur you want to add it, then you can either use this one box blur or Gaussian blur. Then you can use this as a filters. So these are the standard filters already existing in the machine learning. Okay. So usually you can see everyone has a smartphone is there. So in that smartphone, what you are doing normally, usually we are taking the photos. Okay. So most of the some people, what they will do after taking the photos, maybe they apply the some kind of filters, which is already predefined filters available in each and every mobile phone. Okay, so when applying the filters on that one, maybe it is changing the colors kind of thing, changing the sharpness of the image or brightness of the image or maybe clarity of the image, that will be improved. So that filters is already built-in filters. Okay. So that is normally you can see for edge detection what type of filters you are using, or other case what type of the filters is there. So here we can observe. So filter is nothing but the small matrix of size 3 cross 3 or 5 cross 5 or 7, 11 cross 11, whatever it may be. It contains some values. That values is used to extract the particular related kind of information. Okay. Now come to the convolution neural network is the one of the deep learning model. They will call the simple form is the CNN. CNN is nothing but the convolution neural networks. So why are the convolution neural networks is required? Because nowadays the convolution neural network more popular. The reason is the way of extracting the features give the more unique information that are good invariant feature representations are extracting. So invariant feature representation means it is the invariant with respect to the scaling, rotation, flipping, all these variations. Okay. So all these variations are extracting from the your raw input pixel data, means what are the versional input images there. From the image itself they will extract this all variations of the information. So that's the reason nowadays CNN models are popular, because of the way of extracting the features from the raw input data. Okay. So what type of the convolution neural networks is there? Basically initially convolution neural network is only one type only, but based on the data requirement they given the some kind of the types. These are not exactly types, based on the data where you are applying this CNNs. So for example, normally my data is this initially they develop for the images. Image is nothing but what? Two-dimensional data. So two-dimensional data means what? It's contain the rows and column kind of thing. So for example, my image size is 10 cross 10 is there. So in this, how many rows, how many columns is there? 10 rows, 10 columns is there. So that is the two-dimensional data. Then they will build the some filter or kernel of size is 2 cross 2. Okay, this is also 2 cross 2 means it is the 3 rows, 3 columns. So this filter is fitted into the your original image, and you move from the left to right and top to bottom. Two directions it is moving, left to right and top to bottom. So this type of the CNNs they will call the 2D CNN, because you choose a two-dimensional filter, then it's moved from the two direction, left to right and top to bottom. But if you consider the your input data is the text related data or signal related data, so in that case, what is the dimensionality of your data? In case of signal or text, one dimensional. So how we can apply this one dimensional data to the 2D CNN kind of thing? It is possible? It's not possible. Then what will happen? So where the one dimensional data is there, that they'll convert, means resize to the two dimensional data. So when resizing, the size will not exactly fit into the two dimensional. So in that case, what they will do, they added zeros in the corners. They added zeros in the corners to get the proper shape of the matrix based on the your input vector. Then it is converted into matrix. Then again the apply the filter on this matrix to get the or to extract the properties or features. So that is normally in case of one dimensional data they applied this kind of the technique or approach. Okay. So next, but later what will happen? So you are adding the corners to the zeros. Maybe you are getting the some kind of information loss, not information loss. It not give the better results as the accuracy. So your accuracy will be decreasing. So instead of that, converting to the one-dimensional data to two-dimensional, they will take in the one-dimensional data only. My data is one-dimensional data like this. So in this case, they select the filter. Okay, the filter, whatever the filter is there, the filter also moving in only one direction. The filter kernel is moving only one dimension. So this type of the CNNs they will call as a 1D CNN. They taken one dimension data, the filter also one dimension, then it's moving only one direction. Like left to right only it is moved. That is 1D CNN. And another type of the data is there, like medical data, MRI data is there, like dicoma images. Dicoma images, how it is look like, image is there, that is the like a sequence of images is there, that they will call as the slices. So like this, one is left to right, another one is the next direction, z direction, like this is there. Okay, so that is the images of slices is there. So in this case, they construct the one filter. So it is the three directions it will move. Three direction means left to right, top to bottom, and another this Z direction also. So in this case, filter is moving how many directions? Three directions it moving. Left to right, top to bottom, and another Z direction also. So this type of the CNS they will call as the 3D CNS. So like this, how the categorized based on their application only. But these are not exactly types of the CNNs. CNN is initially they were developed for the only two-dimensional data. In that case, filter is moving two directions. But later they will build for the one-dimensional data. One day CNN means in that case filter is moving one direction, and another case is the filter is moving the three direction case. It is they will call the terminology is called the 3D CNN. So what is the advantage of the CNS? I already said it gives the more invariant feature representation that are extracting from the raw input image data. Raw input image data means on pixel level information based on the pixel level information it is extracting the features. That features how it will be look. It is give the more discrimination information in terms of the invariant feature. Invariant features means in terms of the scaling, rotation, flipping, all these variations will be captured from the raw input data. So that's the reason that convolutional neural network are work on different applications. Different applications I mean here you can see like image recognition, object detection, classification, many tasks they apply this convolutional neural network. So how to represent the image? So for example, here image is there. I said is a two-dimensional data, but my image is the color image. So color image is consists of each pixel consists of how many values? Three values. What are the values? Red, green, blue. Okay, each pixel consists of three values: red, green, blue. So how to represent the images? Height of the image, width of the image, and number of channels. How many channels you are using in that image? For example, my image is the binary image. So binary image consists of only two colors. That is a black color and white color. So either it is each pixel contain the white color or black color kind of thing. So in that case, what is, for example, my image size is 10 cross 10. So what is the height of the image in case of binary image? 10. And what is the width? 10. And how many classes is there? Means how many channels is there? Only one channel. Means each pixel contains how many values? Only one value. So that is the binary image case. So another one is the in the binary case it is contain only two colors, either black or white only. And another type of the image is called the grayscale image. So grayscale image is consists of a black color, white color, some gray value also. Okay. So in this case, each pixel contains the how many values? Only one value. So what is the value? The value ranges from the 0 to 255. Okay, each pixel contains the only one value. The values from the ranges from the 0 to 255. Okay, so in case of here image size is 10 cross 10, you can assume it. So what is the image representation of the height, width, and number of channels? In case of grayscale images, height is 10, width is 10, and number of channels is 1. Because each pixel contains how many values? Only one value. Now come to the another kind of image represents color image. So color image here also my image is 10 cross 10. You can assume it 10 rows 10 columns is there. So here what is the height of the image? 10. Width of the image 10. How many channels is there? I said each pixel contains the how many values? 3 values. The number of channels is 3. So like that you can represent the each image is the height, width, and number of channels. So it is clear. Okay. Now go into the CNN models. What are the layers is there? Basically here three types of layers is there. What is the convolution layer, pooling layer, fully connected layer. So convolution layer, this is a pooling layer and fully connected layer. So here I am showing the architecture, then how the architecture look like you can clearly see. So here this is your input data. First you are applying the convolution operation. So you are getting the output. This output, they use a term is called the feature maps. Then once you are getting the output as a feature maps, next they apply another layer, that is subsampling. So this is the pooling layer. So then you are getting the output again the feature maps. Then again they apply the convolution layer. Then you can get the output. Then again apply the pooling layer. So like this convolution layer, pooling layer, convolution pooling layer, like alternative kind of layers is there. Then finally fully connected layer is there. Now I want to explain here what is the convolution and what is the fully connected layer and what is the pooling layer. Okay. So first one is the convolution layer. So in the convolution layer, what will happen? It will do the convolution operation between the image and filter or weight matrix or kernels. Okay, it will do the convolution operation. So once you are doing the convolution operation, what you are getting the output? The output they use the term is called the feature map. Suppose you want construct the T plus one layer feature map. So T plus layer feature T plus one feature map means where you are getting the output. The previous layer output is the current layer input. So you are working for T plus one is T is the previous layer output. Okay, previous layer output and input of this layer. So here this input multiply means convolve with the corresponding filter. So the filter is which layer? T plus one. And after that apply the some activation function. So for example, I put 1 to n pixels is there, you can assume it Ti, Ki kind of thing. So each image pixels are multiplied with the corresponding filter values and take the sum of all the values. Then after that, you can apply your activation function. So that is going on in the convolution operation. You can see here. So this is your input image of size 4x4 and my filter size is 3x3. Same how you are extracting the edge information. The same way you can do the convolution operation here. So what is the 3x3 is? What are the values is there keeping in the 3x3 position like this. So image values are pixel values convolve with the corresponding filter values. So what are the filter values is there here? Corresponding filter values. First one is 1, 0, 0, 0, 0, 1, 1, 0, 0. So you can convolve. How to convolve each image pixel value converted with the corresponding filter value and take sum of all the values. So first row completed. Now come to second row. 0 into 0 plus 1 into 0 plus 0 into 0. Second row also completed. Next come to third row. 0 into 0 plus 0 into 1 plus 1 into 0. So this is 0, 0, 0, 0, 0, 0. So this is only 1, 0. These are 2. 2 plus 1, 3. So 3 is the first output here. Next. So here completion is completed. Then filter is move one step forward. So my filter is comes to here 3x3 again size. How the 3x3 you chosen? Because your filter size is 3x3. So that's the reason you can choose the 3x3. The same way now again the each pixel values convolve with the corresponding filter values and take the sum of all the value. So here what is the value is there? 1, 0, 0, filter values 0, 0, 1 and 1, 0, 0 is there. Then now go to the second row. What will happen? 0, 1 plus 1, 0, 2 plus 1 plus 1. So first row completed. Now come to the second row. 1 plus 0 plus 0 plus 0 plus 0 plus 0. Second row also completed. Now come to the third row. This 1 plus 1 plus 0 plus 0. So this is 0, this is 1, 0, 0, 0, 0, 1, 0, 0. So total 1 plus 1, 2. So that is the second layer output 2. So like this left to right completed. Next come to the top to bottom. Top to bottom is again select the skip the one row and start from the here. Skip one row and start from the here. Again this image pixel values are convolved with the corresponding filter values. For example, your output is 5. After taking the sum of all the values, you can get the output 5. Now the left this part is completed. Move one step forward. Again image pixel values 3x3 selected and convert with the corresponding pixel values and take the sum of all the values. For example, sum is -1. The -1 is here. So this, after the convolution completed, what you are getting the output, this output they will call the, use the terminology is called the feature maps. Okay. So like this you can see 3, 2, 3, 1. So this is the, you can call it the your feature map. So like this your filter is what is happening, moving from the left to right and top to bottom. So it will extract the information which are the more invariant kind of feature representation that are extracted from the raw input image pixels. So like this your filter is moving from left to right and top to bottom up to here. So in this case, you need to specify the 3 parameters when you are doing the convolution operation. So first parameter is called the stride variable. So stride variable, what will do, every time your filter is moving left to right and top to bottom. So once your convolution operation completed, you move one step. So that you decided by the stride variable. Either you want to go one step or two step or three step. Your stride equal to 1 means it will be, once the convolution operation is completed, then skip the first one column, means one step, and move one step forward. Okay. Then again this is completed, again skip one step and move forward again. So s equal to 1 means stride variable equal to 1 means every time once the convolution operation completed, either left to right or top to bottom, it will be skip one row or one column, move forward. For example, in the same case, I chosen the stride equal to, means what? So first convolution is performed here, then its convolution operation is completed. So once this convolution operation completed, then your filter wants to move one step forward. How many steps forward? Two steps, because s equal to means two steps, means it will be skip these two columns and it will come from the here. Again 3 cross 3 selected. So once these 3 cross 3 convolve with the corresponding filters, then it's to get the output. Then after that, again skip these two columns, again start from the here. So like this, every time move from the left to right, two columns will be skipped. Whatever top to bottom. So once this is completed, next come to the top to bottom, it is also skip the two rows and start from the here. Again move left to right with the two skip kind of thing. Once this is complete, again two down bottom. So that is the stride equal to, or you can choose the stride equal to 3 means every step it will be skip the 3 kind of thing. Like you can observe it here. So here first case is stride equal to 1 means it move only one step kind of thing. Okay. So in this case only one step is moving, and another case it move the two steps kind of thing. Okay. So like this is the input image and filter is there moving left to right and top to bottom. Then finally it will be generate the feature map as the output. So this feature map getting means first convolution layer completed. Okay. So like that is moving the left to right and top to bottom. For example, first one is completed. Okay. First what will happen? This 3 will be computed and stride equal 1 means where it will start. Start from the, for example, this is the first column, second column, third column, fourth column, fifth column. So first one completed. Next is start from the second column to the fourth, because stride equal 1. Suppose same case, if I choose the stride equal 2, where it will start after the first one completed, it will skip this to start from the here. For example, I choose the stride equal to 3. So you can see stride equal to, it start from the here, means it will skip the these two columns. For example, stride equal to 3 is taken. Then where it start from here, so start from the first, second, third. It will skip the this 3, start from the fourth onwards. So it will started skip the first, second, third, start from the fourth. So but my image size is up to here is there, but filter came out of size. Then what will happen? It will do the convolution operation or not? It won't do the convolution operation because it's the size mismatch. So your filter sizes came out of the image size. So in this case, you need to specify the one more variable is called the zero padding. Means you need to add the zeros to the all the direction. Padding equal to 1 means you need to add the 4 sides. Padding equal to 2 means 2 column left side, 2 column right side, to column bottom, to column up. So like that, you need to add the 2 from the all directions. Okay. So like this, you can add the zero padding when you have the filter size came out of the input image size, then it will be avoid that issue. So like that, your filter is moving entire space from left to right and top to bottom. Next, another parameter is there, that is called the depth. So for example, here image is there, color image. So what is the color image? Height, width, depth. I said depth or number of channels, both are same. So in case of color image, it contains the depth of channels are 3. For example, one image is there. One image means one matrix is there, one filter is there. So it is convolve what you are getting. One matrix as the output you are getting. Right? But here depth is 3 means 3 matrices is there. White, red color matrix and blue color matrix, green color matrix. So the same filter in case of color images, it convert with this red color and blue color and green color. Then how many matrix you can get as the output? 3 matrix you can get as the output. So here these 3 matrix they will call as the depth. Okay, 3 matrix they will call as the depth. For example, I want the depth is the 50. It's a normal grayscale image or binary image. So if the binary image, grayscale image, when you convert the filter with this image, then what you get? One matrix you get as the output. But I want a depth is 50. If you want depth is 50 means, then what you need to do? You can use the how many filters? 50 filters you can use. Each filter it will be generate the one matrix as output. Then 50 filters, what will happen? 50 matrices will be generated. Okay. Then what is the depth? Depth is the 50. So that is the one more parameter you need to set. So here, what are the 3 parameters at the time of convolution operation you need to choose? One is stride variable, means after the convolution operation, how many steps move forward, decided by this stride variable, either 1 step or 2 steps, 3 steps, it's up to you. Next one is the zero padding. Why you use the zero padding? Because when you are using the stride variable, sometimes your filter came out of your image size. Then in that scenario, the convolution operation is not possible. Then you can add the zeros to all the 4 sides kind of thing. That is called the zero padding. Okay. Next, third one is depth. So how much depth you need to choose it? That is the depending on how many filters you want to use it, you can get the depth. For example, it is a gray color image. Okay, color image means I am using the 30 filters. Then how much depth is get? 30 into 3 filters means 3 depth colors is there. So total 90 depth you can get. In case of it is the color image. In case of binary or grayscale image, you can get the depth is 30 only. Okay. So that is the depth kind of thing. So another kind of thing is, I said, when you are doing the convolution operation, what you are doing, for example, you are doing the L+1 layer means Lth layer, you can take it and multiply the kernel of L+1, and after that you apply the activation function I said. So different activation functions, maybe you know already in the machine learning they apply like linear activation function, non-linear activation functions. So linear activation function is range is the -infinity to +infinity. So most of our real-time data is the non-linear data. Okay. So in that case, we need to go for the non-linear kind of activation functions like a sigma activation function or softmax activation function and tangent activation function. So like that, you can use it the different activation functions. But problem with that activation functions is that at the time of the back propagation, it will get the gradient vanishing problem. So to avoid that one, they used another activation function introduced in the deep learning, that is called the ReLU activation function, rectified linear unit. Okay, so it is also perform non-linear operation kind of things to get the better output. So what is the functionality of this ReLU activation function is, that is a maximum of 0 comma input means. So what are your input values there, that is taken directly. For example, your input value is the negative values there. The negative value is converted into the zeros. Okay, means what? For example, my input is 5. So what is meaning of this one? Max of 0 comma 5. So max of 0 comma 5 is which is the value get output 5. For example, my input is -2. So in that case, what happened? Minus max of 0 comma Your input is minus 2. So which is the maximum value in this both the cases? 0 is the maximum. So instead of taking the 2, then it will be give the output as a 0. Okay, so like this it will be taken the 0, means what here, where is the your input negative is there, negative values are converted into the zeros, only it's contain the positive values kind of thing. So like this, for example, here you can getting the negative, means here getting the black color kind of thing. So in this case, black color means it does not have the black color originally, because of negative values you can get this one. So once you are applying the this ReLU activation function, then what will happen, it will give a smooth kind of thing. So the negative values are removed, means it will give the non-negative and it will give the negative values. You can see here. So this is your input kind of data. So here minus 110, minus 10, like this is there, minus 15 is there. So once you apply the ReLU activation function on this, then what will happen, these values are converted into the zeros. Okay, so like this you are applying the ReLU activation function, what will happen, so where the negative values is there, that will move to the zeros, and what is the positive value is there, exactly that positive value is taken. So this will be avoided the gradient vanishing problem with help of this ReLU activation function. So here different combinations we are taking here. So one is for example here the stride equal to 1, pad equal to 0. So what will happen, this what is the original input size, 5 cross 5, filter size 3 cross 3. So this is input size is 5 cross 5 and filter size is 3 cross 3. So first conversion completed, then getting here. So what is the output size is input size minus filter size plus 1. Okay, so input size is 5 minus 3 plus 1. So what is the 2 plus 1? That is 3 cross 3. So 3 cross 3 is the your output size. Okay, so then your output size get the same as the input size. Then what you need to do, we can add the padding. Now you can see padding equal to 1. Original size is what, 5 cross 5. So padding you can add it means what, all the sides you can add the 1 1 1 kind of thing. So what is the now original size? 1 2 3 4 5 6 7. 2 3 4 5 6 7. So 7 cross 7 is the now changed size. Okay, now filter size already 3 cross 3. Then what is the output size? 7 minus 3 plus 1. So what happened? 4 plus 1. So 5 cross 5. What is the original size? Original size also 5 cross 5. So that's the reason you are getting the 5 cross 5 as the original size. That is the padding equal to 1 you are using. But always padding equal to 1 is help. No, depending on the your stride variable, the size will be changed. Okay, so in this case, stride equal to 1. That's the reason it is working. For example, you can consider here stride equal to, okay, stride equal to pad equal 0, same input size, same filter. Then what do you need to get the output size? 3 cross 3 you need to get, but what is getting 2 cross 2? Why it is happened 2 cross 2? Because of your stride value is changed. Previously stride equal to 1, now stride equal to. So that is input size minus filter size plus 1 by your stride variable. So that's the reason if your stride is increasing, that this value is decreasing. Okay, so that is the reason if you have taken the stride equal to, then it came 2 cross 2. So in this case, if I apply the pad equal to 1, then it's give the input size is same as the output size. No, because stride is increasing, then padding 1 won't work. Then you can go for the padding either 2 or 3 kind of thing, you need to use it. For example, you can see same like a previously pad equal to 1 you are applied. So now pad equal to 1 means what input size is changed to 7 cross 7. Okay, then you can apply the 3 cross 3 filter. Previously what will happen, here stride equal to is chosen, so the output size is 3 cross 3 taken, but 3 cross 3 is the not the virtual image, the 5 cross 5 is the virtual image. Why it is happened 3 cross 3? Because of stride value change. So stride value change, the padding 1 won't work, then you can go for padding 2 or 3 depending on the how much size your input is there, to get the that is same as a your output size, the change the padding size also. Okay, so like this you have the convolution operation is there. Next, pooling layer is there. Pooling layer simply it will do the down sampling. Down sampling means it will input size reduced to half of the size. So this I said your input is multiply the filters and add the bias and apply the activation function. Before that what you are doing, down sampling. So for example your input size is what, 4 cross 4 is there. Then your down sampling means by 2 by 2, 2 cross 2 is there. Okay, so how it will do the downsampling is, that is the three options is there. One is the max pooling, min pooling, average pooling. So max pooling means it will select the maximum value among the 2x2 filter size. It is not do convolution, just it is used for selecting the size. So 2x2 means in the original image 2x2 selected. So in this, which is the maximum value, 6 is the maximum value, then that is your output. So that is the output. Next, you can stride equal to means skip this two column. Next again 2x2 select. So here we are not doing any convolution operation, just we are selecting the size. That purpose only you can use the filter. And stride is you can select it. So in this, which is the maximum value 8, then 8 is the output. So left to right completed. Next come to the top to bottom. So how many column, how many rows I need to skip? 2, because stride equal to. Now start from the here. Then what is the maximum value here? 3. Then 3 is the output. Next again the skip 2 columns. Again move forward here. Again in this, which is the maximum? 4. So 4 is the output. For example, instead of max pooling, I've used the min pooling. Then what is the output values you can get? Instead of the maximum values in the 2x2 matrix, you can select the minimum values. So in this first case, what is the minimum value? 1. Get. Next case 2. Next case 1. Next case 0. Average pooling means you take the average of these 4 values. Then for example, you are getting the average of 4 values. Here is 2, here 3, here 2, here 1, like that is you can get it. Okay, so like this you have the average pooling kind of thing. So for given input data, my input data is this one, 224 cross 224 cross 64. So original input size is 224 cross 224. And what is 64? 64 is the depth. Then after applying the pooling layer, so pooling layer, what will do? It will do the downsampling. Downsampling means only input size is reduced to half. So 224 by 2, 224 by 2, 1112, 1112. Depth will not change. Depth will not change in the pooling layer. Depth will change in the convolution operation only. If you want to increase the depth or you want to decrease the depth, you can use it in the convolution operation place. You do it. Only with the pooling layer, what will happen? It will do the downsampling of the sizes, not in depth. Okay. So finally, it is consists of a fully connected layer. So that fully connected layer is the your neural network layer, input layer, hidden layers, output layer is there. Okay. So like this, you have the fully connected layer is there. So any doubts is there, you can ask. Any queries, any doubts? The participants. Any doubts? Yeah, you can send the message or you can unmute and you can ask your queries and your doubts.
Participants, if you have any queries, you can ask now. If you don't have any queries, we can wind up the session.
Yeah, fine. If you have any doubts is there, you can ask. Otherwise, you can close the session.
Okay, then. Okay, sir, we'll wind up the session.
Okay.
My sincere thanks to Dr. Metu Srinivas, sir, for his knowledgeable presentation. So your expertise is very informative throughout the session, sir. Thank you, sir. Thank you so much. We look forward to continue collaboration and hope to organize many sessions with you in the future.
Yeah. Okay, fine.
Thank
Thank
you.
you, ma'am.
Thank
Thank
you.
you.
Thank you so much, sir. Feedback link will be shared in the chat box and also in the group itself. Shivansh, are you there? Amrut,
Sharing the feedback form in WhatsApp because a lot of people are having issues with the Teams chat. You can directly access it from WhatsApp. Feedback form has been shared. Please